The concept of this video is on solving trig equations, but with a greatest common factor. So one thing you should be thinking about or considering here is that when you have a greatest common factor as your method, you're going to have like a quadratic term, like an x squared, and then a linear term, like a 2x, right? So quadratic term would be something with a square, a linear term would be something with an x, but you're missing a constant term. So if you are missing a constant term, this is where you kind of want to consider GCF. So you still want to equal your equation to 0. So in this case, on this first one, I'm going to go ahead and add cosine squared to move it to the other side. So cosine squared theta plus cosine theta equals 0. Students that I had this morning really wanted to use the substitution method, so I'm going to use substitution and say that x is cosine theta. So this would be x squared plus x equal to 0. The GCF between these two terms is just x. And remember, when you pull out a GCF, it's like you're dividing both terms by x. And when you do that, you're going to be left with x plus 1. Once here, you want to take both the GCF and the binomial here and equal them to 0. So you would have x equals 0 and x plus 1 equals 0. And then go ahead and use your substitution to sub back in that cosine. So in this case, we have cosine theta equals 0, and then cosine theta plus 1 equal to 0. That one we do have to solve, so we would be looking at cosine theta equals -1. This is where you take these two equations to the unit circle and pull those answers. So cosine, remember, is x. So we're looking at where is x equal to 0 and where is x equal to -1. That happens in 3 locations. So theta is at pi over 2, 90 degrees, at pi, 180 degrees, and at 3 pi over 2. Those would be your 3 answers here. Number 2 looks a lot more challenging with there being so many tangents. There's also a radical in this one. So we actually changed this to x right away. So we're going to say that x is tangent theta. So in this case, I have x squared equal to 3x plus radical 3x squared plus x squared. Again, remember that we want to get this to equal 0, so we're going to subtract x squared over. And I'm putting it with this one here at the back because it'll just cancel it out. So this becomes 0 on the left, this cancels out, and I'm left with 3x plus radical 3x squared. The GCF is not 3 in this case because one is a radical 3 and one is the actual 3. So the only GCF we have here is x. And once I divide by x in both of these, I'm going to have 3 plus radical 3x. So I have x equals 0 and 3 plus radical 3x equal to 0. Now let's go ahead and substitute back in our tangent values in for our x's. So tangent theta is 0, 3 plus radical 3, tangent theta is 0, and now let's solve. Tangent 0 is already solved, so that one's good. On this one, I'd have to subtract the 3 over. So radical 3 times tangent theta equals -3, and then divide by radical 3. So this says now tangent theta is -3 over radical 3. That number is not on the unit circle, so we would have to rationalize, so multiply by radical 3 on top and bottom, which leaves me with -3 radical 3 over 3, and the 3's wipe out. That's a lot of work there. So we're looking at where is tangent negative radical 3. So tangent is 0 at 0 and pi. Okay, so theta in this case is going to be at 0 and pi. Tangent is negative radical 3 in the second and fourth quadrant, which is going to be 2 pi over 3 and 5 pi over 3. 2 answers there. And this is kind of how it continues. It just kind of, equal it to 0 and try to pull out your GCF. and most often it's either sine, cosine, or tangent that's coming out. Very rarely are you pulling out a coefficient along with it. So I would encourage you to try more of these on your own. And I have the bottom ones, the answers in, but I'm going to put in 3 and 4 here just in case you want to continue to practice. But I would encourage you to practice these GCF and see if you can get the answers that I've got below. And I will scroll down here in just a second. As always, if you have any questions on any of these, please reach out so that I can assist you in some way. But there are the last 6 practice problems and solutions for those 6.